It is Talk Like a Pirate Day. I won't, I promise. Okay, real quick about me. So I'm a chief application developer at ADP. And as Glenn alluded to, as I was preparing for this, I went back and looked at my old presentations. I did a presentation in 2009 about Hadoop and cascading. That was, I think, the third time I ever publicly spoke. Wow, see, I also have bad grammar. So I would encourage anybody who has a topic that they're interested in, that they want to explain to the community what's going on. So what I'm going to talk about tonight is one of those kind of things. It is an interesting topic. It's something that I learned a lot about as part of a research project. Can't tell you if we used it, can't tell you what we did with it, but it's something I thought was cool and I'd like to share with the community. Okay, so I love this quote because one of the items that I often get in my role is, well, you're responsible for scalability and reliability. What does that mean and how are they different? So Microsoft, as they put out a presentation, came out with a really good definition. I'm not going to read it word for word, but to me the last sentence is important. Reliability is the outcome and resilience is the way you achieve it. Your end users care that you're up. They really don't care how you stay up. They really don't care what it costs for you to stay up as long as you don't keep jacking up their prices. So what we're going to talk about tonight are ways of making sure that you're able to be resilient in order to have happy clients. Okay, so let's talk about defensive architecture. A lot of people, as you stop and think about the things you're designing, probably don't start with, how are my clients going to cause me a problem? However, in a multi-tenant SaaS world, this is a big deal. Prior to ADP, I worked for a company called Silverpop, eventually got bought by IBM, and there we actually had clients who could do a lot of damage to each other. We actually had some clients who thought it'd be fun to try to figure out if they could cause problems for us, right? Multi-tenant SaaS. Can I SQL inject? Can I do, fill in the blank kind of security things? So a lot of your architecture should be around, how can I be defensive? So how do we protect ourselves from our clients? Not just our costs, but our actual employees. So think about an admin. You open up a screen to help an admin. Well, if you've got a SQL injection error, they might be able to attack your internal users and escalate. So what we're going to talk about tonight is nothing to do with multi-tenant SaaS, security, and whatnot. Although if you're very enthusiastic about that topic, I would love to hear somebody talk about this. I did it for many years, but I'd love to hear somebody else talk. So that could be a good topic for somebody. Okay, so let's talk about 3 examples. The middle one, which I think is absolutely hysterical. So the first one, we've got a client who tries to make 10,000 API calls to do something because they didn't read the manual. Dude, we have a batch input. If you'd just given us a batch file, we would have loaded all 10,000 of those in a minute and a half. Instead, you are beating the snot out of us. So I call that the denial of service by RTFM. Anybody in here from South Korea? Okay, this is awesome. Did you know that at the beginning of this year, every person in South Korea had their birthday reset by the government? I won't get into the cultural aspects of it because that's just fascinating on its own, but basically everybody had the same birthday. And they decided that's probably not a good idea, so they actually went back to your actual birthdays. So in effect, they said, okay, instead of everybody's birthday being, I think it was January 17th, we're actually going to give you your real birthdays. So suddenly people who were like, wait, I'm 18 because it's January 17th and my real birthday isn't until July, are suddenly 17 again. So think about what that would have done to your system if you had those kind of users. And we're going to use this as an example later about workload isolation to make sure that not all of your clients got hammered by this if not all of your clients were in South Korea. And the last one is one of my favorite ones that happened a lot. A client has a defect and they basically go into a tight loop, right? So all 3 of these are, one's a bug on their side, one's just wow, something weird happened in the world. And the first one is just silly clients, right? All 3 of these could have taken your entire system down. And when you're trying to figure out what's going on, you probably will have no idea where to start. So we're going to talk about ways to mitigate this kind of actions. Okay, so of course there's always somebody in the crowd that goes, so what, we're cloud-based, let them do it. Let's auto-scale, right? Hey dude, you should have used Lambdas for all that. My favorite, you should have used Mongo. Okay, for those who've been around for a while, you remember the answer to everything in scalability about 2010, 12 was Mongo. So I like to make fun of Mongo, even though I did use it in my last job, and it is, I'm moving too much, aren't I? Okay, and of course, you should just have a cross-cloud architecture. That solves everything, right? So why are we even talking about this? Let's go to the reality. You have a fixed budget. You are not given every dollar that your company is earning, however they're earning that money, right? You have things that you need to play within. So as an example, you may get your business may charge $4 a month per user, but at the end of the day, you as the operations team, the IT team, whatever your breakdown is, get 50 cents of that. And that's fully loaded, which means it includes your AWS costs. It means it includes your network operations team's cost. Because remember, cloud, CapEx and OpEx are very different. It's not, oh, I've got a data center over here, it's $1 million a year, awesome. The way your business probably runs is that they're including all the people necessary to run your product in that number. So what happens if you have an SLA? And you have chargebacks on that, because being good clients now in the IT world that know, hey, outages happen, I'm going to hit up my vendors and get SLA guarantees, and I'll get credits when something goes wrong, right? You have an outage, all of a sudden your SLA chargebacks may be more than you're getting. And then the last one, I love this quote because, especially in the company I work for now, this is a big deal. Every time a person calls your call center to complain that the product is not available, it can cost between $276 and $560, and that number was from last month. So if you've got a whole bunch of clients calling up because that first guy who hit your API 10,000 times in a tight loop took out half of your services, you may now have lost money for that day or that month because 10 people called your call center. So this talk is about defense, about defense, about defense. How do you not let this lead to a discussion at a board of directors meeting or the front page of the Wall Street Journal because you didn't stop something bad from happening? Yeah, doom and gloom, here we go. Okay, first level of defense that you should be thinking about in your services is an API throttle. Is there anybody in here that doesn't have an API gateway? Whether it's the Spring or the Amazon or the Nginx or any of those? So at a minimum, you should have some API throttles there by API and by API key, right? So if somebody does try to do something silly and call you 10,000 times, 100 connections wide, you stop it. You shut them down at the edge, you 429 them, 529 them, depending upon what the challenge is. So that's a minimum. If you're not even doing that, what we're going to talk about next, yeah, you guys aren't even going to be ready for that. The other one is what you'll often hear referred to as dials and levers. Anybody know what that term means? Okay, as you build an application, you think about how many transactions per second I can support. What capabilities should I be providing, right? But you also need to be thinking from a business point of view, what are the limits I should put? So my API throttling is 10 requests per second. It's a good number. Can I change that to 5 if something's going wrong? How many of you have ever been on an e-commerce website and realized that they weren't offering you suggestions right now? You searched for bathroom tools, you searched for impact tools, you searched for clicky mouse things. And instead of getting the 10 or 12 options and hey, based on your prior search, you might like this, you don't see that. That's often called a lever. And what's going on there probably is they're having an outage. They're having a problem in their recommendation service. And they were able to go in and flip a lever, like turning off a light, and turn off that capability, but the vast majority of the capabilities of this product are still available. So being able to go in and say, I have this knob that I can turn down to reduce the overall load, so maybe not everybody's getting impacted. A lever that I can turn off a piece of functionality long enough to figure out what's going on so that people are still using my product. I'm still getting paid. So dials and levers is another minimum kind of thing you should be thinking about in your architecture. Because being able to use these means you can stop a problem before it turns into a full outage. And we'll talk about monitoring in a little while and observability. But once you see there's an issue, what are the things you can play with instead of a panic that the whole product's going down? All right, so let's talk about workload isolation, which is what the majority of this talk will be about. I just wanted to introduce some other things that you really should already be doing before we even start thinking about this kind of a workload isolation. So the idea here is, what can you do to protect your clients from each other when something goes wrong? Okay, so how do you know if you have a defect that affects a very small percentage of your users? And I'll talk about an example a little bit later. How do you stop that defect from taking out everybody? So maybe this one query that's very specific to this type of customer is doing full table scans through your biggest tables and everything starts to ground to a halt. How do you make sure that that one query, maybe it's across 10 users, maybe even 1,000 users, doesn't block the other 10,000 users or the other million users? And that's what we call workload isolation. And more interestingly, or more importantly, is when their business comes to you and says, okay, what's the SLA we can tell people? How comfortable are you coming up with a number if you don't think you can stop something rogue from taking your entire system out? Because you know when it happens, they're going to come back to you and go, wow, we lost $1 million yesterday in SLAs. You told us we should be okay if we told them a second. It got to 5 seconds and they all charged us back. So here's my friend, the recruiter. Here's my HR person, more likely. Hey, HR wants to talk to you. So how do you stop that? So one option we're going to start with is talking about the sharding of clients. Anybody know what I mean by sharding before I get to that slide? Okay, so let's talk about what I'm calling naive sharding. The idea here is you take all your resources and you take your clients and you divide your number of clients by your number of buckets and say, hey, you clients, you're going to have access to resource 1. You also heard this sometimes referred to as the blast radius. When something goes wrong, what percentage of your clients are you going to take out if this happens? So in a naive model, and I'm going to use this as an example, I have 8 copies of my web server, right? They're all out there running, they're all independent. Compute is independent. I then divide my total number of clients by 8 and assign each of them to a bucket. So 12.5% of your clients would be impacted if something goes wrong with one of those buckets. So for some businesses, that might be okay. You might be a startup and say, you know what, we can deal with that. That's all right. But the more clients you have, and that 12% suddenly becomes 1,000 clients or 10,000 clients, you start to get a little concerned here. Now, the reason I call this naive sharding is adding more buckets doesn't really make this any better. It's still a linear math problem. I have to add significantly more resources in order to keep my number of clients impacted within what the business has accepted. Another problem with this naive model is it's really, really hard to get right. Because you might look at your client base and go, okay, everybody who pays me more than $1,000 a month, you get the first 4 buckets, everybody else is in the last 2. Or you may go, hey, I've got all these East Coast users, we're going to put them in bucket 1, 2, 3, and 4. All the West Coast users, we'll put them also in those because they never overlap, right? I mean, there's lots of ways you can think about how do I do a load distribution knowing my clients. The problem is that number changes every single day. You bring on new clients. You have clients that attrit. So you may say, hey, you know what? In bucket 1, we're going to set aside our 4 biggest guys. We're going to give big honking hardware to them. And one of them goes away. You've now wasted a significant amount of money because somebody has to know, hey, wait a second, big client XYZ is no longer here. Let's reshuffle all this and assign people. The even worse part is it's probably going to be wrong. You're going to come in the middle of the day and you're going to look and you'll be like, why are all the West Coast guys here? They're not supposed to be up yet. Or you're going to be like, wait a second, why is everybody hot? Oh, wait, it's the Wednesday before Thanksgiving, and everybody's trying to get their work done because they're all about to go out of town. Oh, I didn't think of that in my sharding model. So now my sharding model's wrong. Now I've got a lot of annoyed clients because this is not optimal. Also, the higher percentage that you get into may not be acceptable to business, and they might be like, no, you can't do this to us. If you have an outage, I don't want the answer to be, well, it's only 12%. Because maybe the guy that is paying you the most money is in that 12%. Maybe the guy who's paying you the most money, who has a buddy who works for the Wall Street Journal, is in that 12% and picks up and goes, hey, dude, guess what just happened? So in general, this naive view is not something you want to do. And I get why you start with it. So let's talk about a model that makes this, and I'm going to be moving around here because I got to point at some bubbles, okay? That makes this a whole lot more interesting and dramatically reduces the percentage of your clients that get hit when you do this. So let's go back to middle school statistics. You guys all remember combinations, right? I have 6 resources, so I have 6 web servers. I want to make them available in combinations of 3. All right, everybody understands that math? You guys all remember that? You know, dig out the brain cells or dig out helping your teenager from a couple years ago like I had to. So in effect, what shuffle sharding says is we're going to take the same idea of defining buckets, but instead of saying it is a fixed resource, we are going to group our clients into these buckets, and the squares are what we're calling the shards, but group the resources in combinations in those buckets. So I'm going to specifically pick on this one. So if this is the shard that you assign 10 of your clients to, when they submit their requests, they will hit resource 2, 3, and 5. Now your first thought is, well, how's that any different? There's 3 servers this time instead of 1 in the previous screens. But look at this. 2, 3, 4. There'll be a little bit of resource utilization contention here, but okay, I'm going to be able to get some work from 5. If I overload 5, hey, check it out, 2 and 4 are still available to these people. So the math of the combination means the small percentage of people that you assign to that shard could be impacted by the outage, but not everybody is. And if you do the math, I do the math up here, I'm now at 1.7%. And that's with 6 servers. I've only got 6 servers in here that are available to providing resources. 1.7% of your clients could be impacted if something goes really wrong. Compare that to the 12.5%, I'm sorry, 16%, because I was down to 6 here. 16% in the naive sharding model. And we have questions about the math here, because this is really what makes this cool, is the idea of the combinations. Okay, so let me show you some examples. So real quick, this is by far not even close to my own idea. Amazon did this as part of their DNS solution. They've got an excellent presentation about it. In fact, several of the images you're going to see I borrowed from that presentation. And the AWS TAMs do an incredible video that goes into a whole lot more detail of the math if you really want to understand the math here. Okay, so how does this work? Inside of the algorithm, they don't talk about a resource, they don't talk about a server, they talk about what they call worker nodes. And the idea being that a worker node is an abstraction of resources that you dedicate to do something. So on another slide in a second, you're going to see I've got an Istio cluster where I'm showing that here are the different worker nodes, here are the pods that are running inside of Kubernetes. When a request is received for that organization, the system says, okay, what shard should this key be in? Whether it's an organization ID, it's an API key, whatever your sharding model is. It then gets the shard and says, okay, what are the worker nodes that are available to this shard? Did that drop out? Are you able to hear me? Yeah, okay, sorry, my echo's changed. But where it gets interesting is when you start to overload the worker nodes that are in that shard, you actually can borrow resources from another shard. So let me go back to the picture, actually go forward this picture. So here's the example where the shards are the blue boxes along the top of your clients. So your client that is Rainbow is done something bad. Either they've triggered a defect or they're just beating the heck out of you because of their requests. In this model, red rows, who's also using that resource on the left, will see some slowdown. A sunflower also starts to see some slowdown. But by having a good retry mechanism built into your infrastructure, and you guys do have retries, right? You've got timeouts, you've got circuit breakers, again, table stakes just to get into this discussion. When the platform detects, hey, wait a second, I've got an issue here for this guy, it routes it here, and I succeed. Rainbow has completely destroyed these two. Nothing is getting to them. But Rose and, where's the other one? Thumbs Up are now able to, Rose and Thumbs Up, Rose and, Flower are able to get resources that Rainbow isn't able to touch and damage. So 1.7% of your clients in the model we're talking about will have a problem. Everybody else isn't impacted. No, but I'm sure you say, wait, retries. You're talking about retries, you're talking about timeouts. So yes, there is the timeout that says, okay, I tried to reach the one all the way on the left. It timed out. Now I'm going to reroute to, in this case, this one. So yes, there's a little bit of time in there, but you should have built into your system, in general responses, retry time, in number of retries before you fail, all that stuff. Does this make sense so far? Any questions? So hopefully by now you're looking at this and going, okay, but wait a second. Nobody's using these guys. Why can't I take these guys to help out Rainbow? And that, unfortunately, is the downside to this kind of model, is you're going to set aside some percentage of your resources just in case. You're going to not say, hey, it's time to take all those resources and help out Rainbow, because you don't know that Rainbow could actually then take every other resource and completely take you out. So there's a little bit, and this is a fun discussion with the business, which I most recently have had, to say, hey, yeah, we're going to sit some resources out there, but at the end of the day, when something goes wrong, I know I can limit it to X. I know I can mitigate X, and I'll talk about in a couple slides the ways you mitigate using this. We still stay up, and our SLA impacts is 1.7%, not 15% or 25% or worse, 100%. In fact, I even talk about, yeah, this isn't about socialism. This isn't everybody gets the same amount. This is making sure when something goes wrong, you can recover from it. And also, yes, the shards, the worker nodes that are in those other shards do see some load. You will do it into the timeouts. But from an end user's perspective, their work is still happening. They're still happy. Okay, let's talk a real example. So left side, got an API gateway. The requests come in through the API gateway. I take the organization ID or my application key, go to my sharding service and say, hey, for this organization, what are their shards? It's going to reply back with, sorry. All right, it's shard 1, and shard 1 is associated with worker node 1 and worker node 2. So then Istio, basically the gateway routes to Istio. Istio looks at the header and says, okay, I'm going to worker node 1. Goes up to the top. Worker node 1 is made up of 2 Kubernetes pods. So those are dedicated resources. Those resources now do what they're going to do, right? If that first service now needs to make a call to a second service, this is where this gets really cool. It passes along in the header, hey, we are part of shard 1, and we have been assigned worker node 1. So now when it routes, again, here's the second routing over to Istio, in the second service, it routes it again to worker node 1 at the top in 2 pods. So the idea behind a shuffle shard flows throughout your whole architecture. So that way, if the problem is actually on service 2, only the people coming through service 1, worker node 1, see the problem. It's not a random assignment out of service 1 over to here, because then you get into combinations where your patterns explode, and then the math turns into tens of percentages instead of single-digit percentages. So let's look at the second example. So here comes the second request, the red. Same request to the sharding service. By the way, you cache the hell out of this. There's a big old cache in the gateway to handle this, so you're not continually querying that service. Routes to Istio, except for this time, because it's randomly assigning worker nodes as part of the routing, it routes everything to worker node 2. So now worker node 2 for service 1 calls service 2, and service 2 is running really, really slow. Whatever it is about this request on worker node 2 is running really, really slow. Now, it may not even be this organization's requests that are causing the problem. It may be somebody else, right? Because we're multi-tenant. When this times out, service 1 goes, oh, whoops. Okay, I was on worker node 2. I'm now going to change to worker node 1 and retry. So he now routes up to worker node 1 and succeeds. Because the bad actor has beaten up virtual service 2 worker node 2 of the virtual service, this redirection means the request goes through. Making sense so far? Now, let's be clear, this is not a silver bullet. If whatever the problem is systemic, so the query that everybody runs is bad. If your real problem is actually your SQS or your SNS to SQS publishing, and that's a centralized service, this doesn't help. Now, you still should take your message queues and dedicate message queues to your worker nodes. So that way it's not a question of, oh my gosh, there's 10,000 events in the queue, we just can't get to them. But if there's a problem systemically that is across everybody, this doesn't really help. Excuse me, hold on. As I mentioned before, you still got resources sitting around just in case. And the finance guys get winds of us. They're like, yeah, but your utilization's at 45%. You know, typically for industry, 65 is normal. Well, you're right, but we're at 45% because when things go wrong, and we all know things go wrong, best effort or not, things go wrong. When it happens, we'll be able to only impact a certain percentage of our clients. And most finance guys get that once you explain it in terms of pay me a little bit now, where the SLA charge is when this goes sideways and you have all your clients calling at the end of the day. Also does not protect issues that impact all of the clients or that are shared resources. So this is not a pattern for how do I take my database and make it more resilient or make it more resilient to less impacted by a client doing something wrong. That's a whole other set of patterns. Database sharding. Self-call out here, if you go back to my presentation back, I think it was last February, a year ago, we talked some about database sharding. But the idea here is this is about compute. So again, no silver bullets. Questions so far? Okay, so let's talk about the example that, if you look it up on the internet and start searching for shuffle shards, this is the one that's going to come up because Amazon, once they explained what was going on here, got a whole lot of press. And arguably, I think they say that they've invented it. I'll give them credit for it because I still think it's pretty cool. So you guys know about Route 53, right? That's Amazon's DNS service. Billions of DNS lookups an hour. Millions, tens of millions of websites that they host. So guess what that makes them? A target for denial of service attacks. Right? For whatever reason, your website has annoyed the script kiddie over there who goes and buys for 50 bucks, 1 terabyte denial of service attack. So, and guess what? If that's hosted by Amazon, you could have knocked over Amazon DNS. Yeah, how well would that go over? And being Amazon, they're like, no, we're multi-tenant from day one. We're massively scale multi-tenant. How do we not let that happen? So what they actually do is with 2,048 worker nodes, and in this case, a worker node is an actual EC2 instance. They have 730 billion possible combinations with only 3 worker nodes in that combination. Remember the bubbles I was showing you before? I only showed you 6, and we had 56 combinations. This model means if you denial of service an Amazon hosted DNS, their monitoring will catch it, and really quickly they will swing their load shedding tools in, knowing that I'm only worried about this particular organization or these particular domains. They have protected everybody else who's hosted with them. Now, of course, in the presentations that Amazon has done in the public, somebody will be like, well, why don't you just leave the load shedding tools always there? Those have latency costs. They have to look at every packet. They do deep packet inspection into each one of them. They're expensive. So rather than sitting around with the expensive resources waiting for something to happen, they assign every DNS their own shard, every domain their own shard, and wait for something to go wrong, and then automatically swing in the load shedding tools. So as I understand it, when somebody DDoSes an Amazon-hosted domain, they detect it within a few seconds and swing the load shedding stuff in front of it to shut down those kind of things. It's not, oh wait, here comes the engineers are digging in, wow, look at that traffic, that looks weird. Nope. In this model, they say, because I've got dedicated resources, if I see something unusual, swing the load shedding stuff in and then we'll get involved. Any questions on this one? Okay, so happy birthday. This one I think more people can wrap their heads around. So first thing is, the client who is now calling into your service saying, hey, update everybody's birthday, should hopefully have been throttled at the API gateway, right? So they're not 100 wide, just absolutely slamming you with 1 million people that are in their database. So some amount of them are coming in here. So that do work, the ones that do make it through are routed to a worker node. Those worker nodes start to get busy, because if you think about what could go on inside of a profile update, in this particular example, it is a website that has controls by your age. If any of you have ever had to deal with government or regulations which say, hey, if they are 14 or under, you only can see X, or if they have to be 18 or older to go here, this was a nightmare. Because yesterday, all of the people who were born since January 15th, and again, I think that's the date, were all 14. Today, they're not. They're all 13. And since we're talking about government stuff, you don't want to make the mistake of saying, yeah, we showed all the 13-year-olds things that according to the law we weren't supposed to. So you're going to fire your Drools engine that runs and looks at all of the things to figure out what capabilities these users should have. So think about what that means. Millions of requests into a Drools engine, which is not web speed. It's not slow, but it's also not, transaction speeds. Starts to back up. If I don't have this isolation of this client's work, so their Drools engines are in worker nodes, if I don't have that level of isolation, it starts to take out everybody around me. And suddenly, this one client who didn't think anything of, wow, I got to update my birthdays, I've taken your website down. Second client comes in, similar problem. All of their users are South Korean. They run the exact same logic because, hey, they've got the same problem. Shuffle sharding means that we will route their traffic to a set of worker nodes, overload those worker nodes, but when the third client who comes in, who is not from South Korea, again, multi-tenant SaaS, right? We got clients all over the world. They get routed, they do whatever it is they do, their Drool engines run. They're not impacted by this because those first two clients are in different worker nodes. So I've got a massive load. It's not a bug, right? This isn't a problem we deployed bad code. This is a usage problem. We have now protected a large percentage of our customers from the activities of a few. In a second, I'll talk about what the problem is if you do have a large number of South Korean clients, all of who hit you at the same time and take out all your worker nodes. We'll talk about that in a second. Questions about this? Now, the last comment is an interesting one because as I was reading through this use case, I was like, yeah, why don't they just flip the lever that says, you know what, we're going to hold off on doing that for right now. Maybe we're going to turn off those capabilities for the people who are 14 or something. If you had the lever, remember we talked about dials and levers before. If I'd had the lever the first time that this hit, or better, since I know I've got South Korean clients, I would have been like, hey guys, what are we going to do when half the world or half of our client bases changes dates? Let's turn off that feature and figure out how to deal with it later. If I had the lever, I would be able to just go, all right, turn that capability off. That make sense? So the idea of taking the basics to solve a problem that, yes, shuffle sharding helped mitigate, but having that lever in your hand also meant it may not have been an outage for those first two clients. They may just had a degraded experience. Okay, so let's talk about dynamic sharding assignment. This is an interesting one. If you do have clients, and I'm sorry, it's an eye chart. Anyways, if you do have clients that have predictable patterns. So, for example, if you have clients that, because of the nature of your business, Monday, Wednesday, Friday, 7 to 9 a.m., East Coast is the biggest time for the East Coast guys. 1 to 2, Monday, Wednesday, Friday are the biggest for the West Coast guys. Or you know that all of your clients that are coming out of Europe do something on Thursday mornings, or whatever the patterns are that your data scientists find. And by the way, this is an excellent machine learning process. Get your your data scientists and go, hey guys, can you look at our traffic and find patterns? Right? They're really good at that. Point them to your traffic and say, find me some patterns in there. And because the sharding is assigned dynamically, I can go in and take those patterns and say, hey, it is Monday, 7 a.m. or 6 a.m. Change the sharding layout for these 10,000 clients, spread them evenly across 90% of my capacity, because I know there's a real good chance my other 50% of my clients aren't going to show up today at this time. This is a change to the cache, right? You're shooting the cache. First time they show up, they're assigned a new worker node, a new shard, which is new worker nodes. So now I'm able to, with a little bit of knowledge, and by the way, when you get this wrong, shuffle sharding will protect you because you will have overloaded a different set of worker nodes than you thought you did. You now are able to adjust your loads in anticipating what's coming. Adjust your resources anticipating what's coming. And like I said, when you get it wrong, be able to recover. This is also interesting when you have that overload. So let's go back to the example with the happy birthday. If you didn't know that this was coming, and you start to see a pattern of, whoa, everybody from South Korea is doing all of these requests. They're doing this expensive operation. Why don't we just take all of the clients that are coming from South Korea and throw them in 5 shards? We know their experience is going to be bad for a little while, but the other 50% of our clients are still going to be okay. Here I've deliberately said, I'm going to make some of my users' experiences worse to protect my base. Again, this isn't socialism. This is about making sure I am able to survive a bad experience. So, bad query mitigation. So any questions on that last one? All right, let's talk about a bad query mitigation. This is another use case, and this is one actually I have some experience with. There's something specific about a client and an action that they are taking that causes your system to have problems. I'm going to use a specific example here of, say you're a software that is used by people who are writing tickets. So as the meter maids are going around and writing tickets for people illegally parked, you're getting those requests and you're sending them bills, right? Because you don't want to do that in batch, you want to send it right away. What if the fact that the New York City fine calculations during the surge window, which I think is 9 to 4 during the day, I forget what the rules are in New York, causes a problem? There may only be 1,000 meter maids in New York walking around at any given time, and maybe this is an application that's used all over the country. You don't want those meter maids, as they're writing up the ticket for that person, to take your whole system out. So back to the previous use case, you isolate those clients that you know are in New York. Your dev team is now going, okay, we see what the problem is. This is a bad query, we want to change the query. Okay, again, back to basics here. You blue-green deploy that change only. If you look back at that picture where I showed the pods in Kubernetes and those virtual services, you guys should be able to blue-green deploy to a Kubernetes layer, right? Your virtual services and your pods. So you apply this code and deploy this code only to the New Yorkers. Now you hope it works, right? Because this is a rush, right? Yeah. How many people have ever patched in production without going through QA? You're lying. Nobody put their hands up. You're all lying. No, the website's not down. Meanwhile, the guy over there is rebooting the Apache Tomcat. No, we've never done that. If it works, great. Everybody takes a deep breath. Now you get back in your process. QA gets involved. You write your use cases to make sure everything works the way it's supposed to. If it's wrong, yeah, well, we can try again. But we didn't just go through a massive deployment, redeploy all of our pods, shut down all of our users, and maybe introduce a bigger problem. We've only deployed to those handful of worker nodes that are part of that shard. Now, the last piece in a bad query is maybe you can't figure this out. And you make a decision as a business, we're going to throw resources at this. So I'm going to go into those Kubernetes pods, and I'm going to double the memory that they have. Or I'm going to go in and say, okay, give them 2 more database connection pools, because we're seeing our timeouts of, or our wait queues on the database connection pool gets at 2 to 3 every 5 seconds, the kind of metrics that you collect. All right, we're going to make a decision to go do that. Well, assuming, again, you're using something like a Spring Cloud config or another tool that allows you to just run and restart those pods, I am now only impacting those clients that are causing the problem. Now, the other side is you're like, you know what? We really have no idea what's going on, but we've got to stop this. So you go in, you take the database connection pool down to 3. It's normally 10, you take it to 3. Some activity still going in, you start to see timeouts. The experience for these guys is not great, but now you've protected your database. By being able to dynamically say, for these clients, here's the resources I want to give them, and play games with the configuration of those resources, you have now been able to protect your other clients from these clients. Any questions about that? Okay, summary. Stuff happens, right? This is a mitigation when things go wrong. Whether they are malicious acts, whether they are people who just don't know and it's an innocent mistake, or it's a bug you guys released. Things happen. You guys are doing outage simulations, right? You've got the runbooks built that when something goes wrong, and by the way, if you did any of these previous ones where we talk about dynamic stuff or playing games with queues in database connections without having done it in a test environment, you're crazy, because your chances of getting it wrong are really high. But if you've gone through an outage simulation that says, okay, we're going to deliberately isolate the traffic from South Korea. X, Y, Z, here's the pipeline I run. Watch the pods rebuild. Okay, we're comfortable we can do this in a battle. But outage simulation is a critical piece of being able to do anything in some of the more interesting things we just talked about. As I said before, this does not make all clients equal. It just makes sure when something goes wrong, you stay up. Again, back to resiliency. And it sits on top of a very strong patterns of retries, virtual routing, blue-green deployments, API gateways, all the stuff that is the core of your architecture that has absolutely nothing to do with the thing people pay you for. But when they come back to you and ask for an SLA credit, they don't care. Oh, what do you mean you don't have virtual routing? You don't have a database shard? You don't do retries? They don't care. They're like, give me my $4. My user was down this day. Your SLA says you're going to credit me. Give me my money. And of course, observability and monitoring are critical to this. Because how do you know what's going on if you don't have that tier? Yay, the shuffle shards made sure not everybody's out, but why? What is the problem that's causing these 4 worker nodes to be hot? Anybody know? I don't know. Let's go look at the database. I don't know. Let's go look at logs. No. Get your observability and your monitoring in place. And of course, the last one, if your data tier isn't robust, you can still knock it over. Yes, sir?
Let's say we're going to introduce it to our company. We've got the QA, we've got the stress testing, it looks good. So it's time to get it to production. Is there been any discussions on, okay, we'll take 10% of our traffic and start routing it to shuffle sharding, or is it 20%? How do we determine the level of introduction into production?
Sure, so Glenn's question was, If you're ready to go to production, how do you not big bang this? Because this in and of itself is a pretty significant architecture change. The cool thing is, you see the little Istio box? Istio routing, and the reason that this works so nicely with the Istio virtual services is that Istio routing box can do 10% of the traffic. I don't care what worker node you tell me. I'm going to ignore that and route it to my existing worker node 3. So that's my existing logic. I've taken 10% of my resources. In this example, 30%, sorry for the math. But so the first two, worker node 1, worker node 2, are now part of the shuffle shard deployment. Worker node 3 is not. So all traffic that we don't explicitly route to those two is still going to go to the existing logic. Reality, that would be 80, 10, 10, or heck, even 95, 5. But the idea now is you can watch Istio, and Istio will log, I routed it this way. I retried and routed it that way, and you start to see if this is working. And back to your observability and your monitoring, you should then start to see the worker node as dimensions on your micrometer. I'm getting way off into the corner here, but as you're deploying all your micrometers, add a dimension for your worker node. So now I can go and look in Grafana what my worker nodes are doing relative to everybody else. Did that help? Other questions?
So how does it work in the case of disaster recovery? So you have, for example, 2 regions.
Yep.
And certain two regions in different, like US coast and West Coast and East Coast.
Yep.
So you should keep the same replicas in both of them, or you shuffle shard in both regions? Or it depends. Like there's no silver bullet.
Right. So no silver bullet. But my first thought on that would be whatever is the tier that is deciding East Coast versus West Coast in your DR is part of the algorithm where you assign the shuffle shards. So back to that data science discussion, when the data scientists come in and we ask them to look at the load patterns, as part of their algorithms, they would say, you know what, 50% is East, 50% is West. And again, this is where your runbooks coming out of an issue come into play. Now I want to change the shuffle algorithm to do 80% West because we're coming up slowly in the East. And because the sharding service, which assigns shards to clients, is dynamic, you can shoot that cache every 30 minutes and go to 15, to 20, to 30, to 40, to 50, and then be up. Meanwhile, if there's a crazy volume that came in because the clients that were down, or maybe they weren't as performant as you wanted, comes in, the overall concept of shuffle sharding and workload isolation will start to protect you. It's not that your East Coast is suddenly going to get slammed with all the traffic and it's going to go down. Not that that's ever happened when we failed over, right? All of a sudden, all the traffic knocks down the DR site because, oh crap, we didn't build the DR site to handle 100% of the traffic in 30 seconds, because that's what's about to happen to it. Okay, other questions? Well, thank you very much. I appreciate your time, and I enjoyed talking about this.
Give them a round of applause, guys.